How did you do with the synthetic division? Good. So the red numbers there are remainders. Now, when you plug in p of 1 into this equation here, notice you get 0. When you plug in 3 into this equation, you get 4. And when you plugged in negative 2 into this equation, you get 0. What do you notice about those numbers? Absolutely nothing, right? They're the same as the remainders. Okay. That was really obvious? Yeah. And that is, this idea is called the remainder theorem. So this is on your next page. If you want to highlight it, you can. The remainder theorem. When something is divided by a binomial, if you plug that value into that polynomial, you get the remainder. So what does this look like with our questions? Well, that really gives us two ways to find the remainder. And so we'll do both of these questions with both methods. You can find the remainder using synthetic division, or you can find the remainder using the remainder theorem. And so I'll do the first one, and you guys can decide which one you like better. And there's going to be times where one is better than the other, and other times where the other one's better than the other. So we need to know them both. But using the remainder theorem, if I call this polynomial p of x, so I'll just sort of say let p of x equal that, then the remainder theorem says if I plug in 3 into that polynomial, I will get the remainder that you would get if you divided by x minus 3. So what would that look like? That would be 2 times 3 to the power 4 minus 5 times 3 cubed minus 5 times 3 squared plus 5 times 3 plus 3. Three to the 4 is 81. 81 times 2, 162. 3 cubed is 27. 27 times 5, something. Good. 3 squared is 9. 9 times the negative 5, plus 15, plus 3. And nice. We get 0. If we did synthetic division for this one, we would have 2, negative 5, negative 5, 5, 3, and we would put a positive 3 outside. Bring down your 2, multiply, add, multiply, add, multiply, add, multiply, add, and we get the same remainder. Looking at both of these, which one did you like better? The synthetic division, right? Maybe it seemed like it was a little bit faster. The biggest mental math you had to do, 3 times 2. Ooh. 3 times negative 2, that's probably harder. 3 times 1 was harder? Yeah. That. And then, I mean, the biggest adding you had to do, which was the hardest adding? Negative 5 plus 3, was that the hardest adding?
5 plus negative 6.
5 plus negative 6. So we had some tough adding in there, definitely some tough adding. Whereas over here, biggest multiplication, you had to do 3 to the power 4, 81. 81 times 2, 162. That's pretty big. Biggest subtraction, 162 minus 35. So it appears in this one, the synthetic division is a little bit nicer. Okay, let's look at part B. Part B, we're going to find p of negative 2. So you would have 2 times a negative 2 to the power 4 minus 5 times a negative 2 cubed minus 5 times a negative 2 squared plus 5 times the negative 2 plus 3. Negative 2 to the 4 is 16. 16 times 2 is 32. Negative 8 times 5 plus 40. 4 times the negative 5 minus 20 minus 10 plus 3 equals 45.
Oh, I see that. 42 plus 3.
Now, let's look at our synthetic division. So we had 2, negative 5, 5, 3. We're dividing by x plus 2, so negative 2 would come out here. And bring down and we got the same remainder. Second example, probably still like the synthetic division better. I mean, it got to some bigger numbers here, definitely some bigger numbers this time with synthetic division. Why is the remainder important to us? Well, if we can get a remainder of 0, which we did in these examples here, 2 of them had remainders of zeros, then that tells us that these are factors. Because when we write our division statement, let's look at the division statement for this very last one. If you divide 2x4 minus x cubed minus 17x squared minus 11x plus 6 by x plus 2, and we write the division statement, okay? Are you okay with me, instead of writing all of this, just going p of x equals, and we divided by x plus 2, and then we got 2x cubed minus 5x squared minus 7x plus 3, and then remainder 0 would mean there'd be a plus 0 out here, which you wouldn't have to write. And if you didn't have that, what have we done? We have just started to factor that. We found one factor. So if the remainder is 0, then you can factor it. But you wouldn't be done factoring it, because then you would have to still see if there was something else that worked for that. Whew. And then we have to see if we can factor that further, or if this is done. Well, no, we couldn't divide this one by x plus 2. It wouldn't factor. We'll get there. We'll get there. But right now, we've just finished this, the remainder theorem. You have 2 different ways of figuring out the remainder, either synthetic division or with the remainder theorem. So you can do 4a and 6a, 7 and 8.